Hey, good morning. Okay, so what we're going to do here is we are going to update the Linux kernel on one of my Gentoo Linux computers. This computer that I'm updating this on is an Intel i7 first generation 920. And you can see that by typing this command. And that displays the host name, the kernel version, how many times it was compiled or updated for the same version. So if I had to make an adjustment, it would be the second time. SMP means that it's symmetric multiprocessing capable because it's got more than one CPU core. The date that kernel was compiled, so the last time I updated it was on January 27th. At what time, the time zone, the architecture, so it's x86-64 or 64-bit. It's an Intel CPU type and so on, right? So what I've done here is I've just installed all of the updates. I've purged old updates before I'm going to start building the new one. So Linux kernel sources with this distribution, being that it's a from source distribution, allows you to make any changes you desire because you've provided the source code at which or from which you can customize, adjust, and configure it to suit your needs, the hardware that you're running it on, and so on. So if you can see from the above notice, it says note even though you successfully unmerged, which means uninstalling old sources, right? The source for the old kernel version remains because it removes it from the software install database. However, it doesn't remove it from the system. So Linux kernel sources are always in the directory usr source. A lot of Linux directory names are acronyms for things, and it differs from Windows in the sense that drive letters are not something that Linux uses, right? So we want a long list. That's what the root of the Linux file system looks like. It's just named directories, and each directory having its own purpose. Excuse me. So what we're going to do is we're going to look and see eSelect. This is a tool for managing this distribution and various environment variables and configuration settings to change, say, your graphics driver settings, kernel versions, which Java version your OS install uses, and various other things. Or in this case, the kernel, not kernel version list. So because I've removed the old one, there's one remaining, right, which is the one that was installed. So I'm using the bash shell again, bash shell environment, or born again shell is its longer name, bash being the acronym, and it allows you to type a couple relevant letters and press tab and get directory name completion or line completion, right? So you can see here that with this, it's currently configured in the environment to have the Linux kernel directory symlink, or a symbolic link, meaning that it's pointing towards a real directory. Symbolic is configured to use the Linux kernel version 4.14.15, but I want to switch it to 4.15.2. That symbolic link has to match the version that you want to update to, or you want to configure. So what we do is, with this distribution, it has tools to manage doing that for you that makes it a little easier to do. just set, and then the version that's listed in the eselect kernel list command, right? And there, it's updated because it's got the little star next to it. So now what we do is we change directories to user, source, Linux. And you can see by listing the directory that's one above the one that you're currently, that's currently your present working directory, it's updated the link to show that it's at 4.15.2, which is what we want. So pwd, show your present working directory, right? So now we need to import the current configuration for the Linux kernel into the present working directory, so that the configuration option specific to this computer will be used when the new kernel is built. There's a configuration option with the Linux kernel to provide a compressed kernel config in the running kernel itself. And this proc is a file system that's, I guess, a virtual file system in a sense that it provides environment variables, configuration things and such relevant to processes and running functions that the computer needs to supply information to applications to complete and maintain processes and tasks. Best way I think I could think of to explain it, right? Or in this case, you can see there's quite a lot of stuff. That config.gz or gzip config file is the actual running kernel configuration, right? But it's gzipped. So what we have to do is I have to get the raw text uncompressed config, and I use that using a command called zcat. Right? Now, if we zcat that, it's going to uncompress it. But what we want to do is pipe it by doing this, and that sends it to somewhere. And then we want to send it to .config. And there's the config file. So now that we have the config there, as can be seen by this, which wasn't there before, and I should have shown that, but still, don't make these videos often. What we want to do is type make menu config, and what this will do is it'll initialize the Linux kernel source directory to recognize the config and prepare it for compilation or building into an executable file. And this will also load a menu, which is where you would typically configure the Linux kernel options, and there are a lot of them. So, and learning this takes time, but it's something where you can just go section by section, and eventually you'll learn what the different options are and which ones are relevant and which ones are redundant or bloat. And in the grand scheme of things, with this in mind, there's a general rule of thumb. I enabled it because it looks cool, and if you adhere to that rule, you will often find yourself with something that works fairly well. So what we're going to do is we're just going to exit and save it, because we're not going to make any changes, even though that it's a major version upgrade from Linux 14 to Linux 15. There shouldn't be any major changes necessary. Maybe some small ones to change minor features, but for all intents and purposes, it should be fine. So to compile the kernel, what we have to do is type make, right? And what we can do to help speed up this process is spawn more simultaneous processes to compile drivers or portions of the kernel, since the Linux kernel has an architecture design that uses loadable modules as needed when they're required, and that reduces the memory footprint for the running system, makes it more efficient, and so on. Now, one thing we have to consider is installing the kernel, right? But what we'll do first is just make dash J8, and I want to do 8 because this is a i7 Intel. It's got 4 real cores and 4 hyper-threaded cores, or 8 threads simultaneously. So this can take some time, and maybe 5 minutes, 10 minutes possibly. So it goes through, and anything that is marked M in parentheses is a module or a modular component, and it differentiates those and builds them into modular components that are drivers for things that you may need occasionally, or some piece of hardware may need occasionally, or may need to be configured as modular so that it provides functionality that will work the best for a certain piece of computer hardware. Man, it's getting kind of warm in here. So this isn't terribly entertaining, but you can see for the most part with Linux, if you're comfortable with using the command line, you don't actually need a desktop graphics environment or graphical environment and a monitor. You can just log in remotely with a text command console and accomplish pretty much just about anything. This, as well as setting up remote graphical desktop environments by using text command consoles. So this command will just build the Linux kernel and its modular drivers. After which we'll look at how you install the updated kernel and how you ensure that the bootloader configuration is updated so that it's able to recognize and boot from the new kernel. You can maybe hear in the background my older. This is one of my older computers. It's still pretty beastly, very capable. Doesn't get used a lot because it's an older BIOS-based motherboard as opposed to UEFI based motherboard. So, and I've got newer computers as well, but it's still working its way through all of this. You can probably maybe hear the CPU fan in the background. Now there's no progress bar, unfortunately. Progress bars would be nice, but you can, after doing this several times, kind of get a grasp of where it's at in the progress, or at progressing through completing the build task to build a new Linux kernel and modular drivers. And this is one of the things that makes Linux and open source operating system so great, is that everything that, for the most part, with some exceptions, that makes the Linux kernel excellent is that all of the drivers for things are openly provided, right? That's the open source advantage. So now we're just going through IP version 6 config. NetFilter is like firewall stuff. Trying to recognize some of these other things that are here. Reading all of this tiny little text isn't always easy. Hardware monitoring, like temperatures and so on. We're getting into file system drivers now, I think. NTFS drivers. Network file system, NFS, different versions of that. Wireless drivers. All of these drivers for different types of hardware, and there's more hardware drivers in the Linux kernel than I would ever know what to do with, despite being able to do this. Networking drivers. Fortunately, I think that this configuration for this PC is a little bit more lightweight than some of my newer computers. The newer computers tend to need more configuration options because of UEFI motherboards. So that makes the compilation or build time take longer on a newer computer to build the necessary things. So USB stuff, USB drivers. You know, that menu really, like, you get a new joystick and you don't have a driver for it. You just go in the menu, find your joystick, search for the driver that it's used with, include it as a module, and rebuild and reboot, and it's done. And you know, after that you configure it. So there we go. So that's everything built. Now it's building the actual binary and packing it all together into the bootable kernel executable. There we go, and it's built. So we can see there's the results. VM Linux. That's the actual Linux kernel binary. Now what we have to do is we have to install the kernel and its modules. So this will install the modules in the directory where they will be housed, and I'll show you that directory after, and it will install the kernel binary or executable in the directory where that is supposed to reside. There we go. So the boot directory, that's where the Linux kernels are. So you can see VM Linux 4.15.2-Gentoo, that's the one that we just built. And what it does is also installs these other files. It installs a text config, a copy of the configuration that was used to build the kernel, so that if you ever need that for reference later or for utility value, you have it. And oops, not LDLS. Right, and that's where the modular drivers go. See, there's the kernel, and it's just by category. So I don't know, which category? Let's do FS, or file systems, right? So different file systems, network file system, squash FS, so and so on, or CIFS, which is like Windows file system sharing, or being able to use Windows file systems remotely over a network. So that's all that stuff. So there we go. Now, to update the bootloader config, we use this, which ironically is named grub-make config. And we want to output that to a file. In this case, it's in boot and grub.config. And that generates and updates the configuration for the bootloader. So when it loads, it knows that the new one exists, or new kernel version. Now what we have to do is, if there's any third-party drivers to reinstall, so that the kernel version that's been updated is able to provide those. In this case, this computer has a Nvidia graphics card. So we can see that by listing the devices, hardware devices on the motherboard, or that are attached to the motherboard, like the Nvidia GTX 750 Ti that's in this thing, because why not have a 750 Ti in an old computer? We know that we need to install the Nvidia graphics driver. And we do that by using the software package manager. And what it'll do is download the driver version if the file necessary doesn't already exist. Unpack it, prepare it to be built in much the same way that we just built the kernel. It's using the new kernel version, and it will automatically configure it and install it all. So it checks the configuration options for the kernel we just built to make sure they're appropriate, make sure that the version of the kernel that we're using is acceptable, and that the configuration options are acceptable. And it builds the driver software, builds the graphical management interface to manage your fan temperatures and look at your graphics card thermal settings, overclock settings, and so on. Right? And this is, again, building the C programming language code into machine language, matrix type. That's what compiling is. It's going kind of slow, but some of these compilations or builds are pretty beefy for some older computers to undertake. Code gets more complex as computers progress. With newer hardware and so on. Excuse me. So just a bunch of warnings there. Nothing to be too concerned about. Sometimes the software that's able to do this progresses faster than people that make this code are able to update it. And there we go, build complete. That's why it was going slow. It was using my distributed compiling setup. I've got a faster server in household, and it installs the driver, configures the graphical interface, subsystem configuration to use the new driver, and that's that. Now, this system also uses ZFS file system on Linux, I think. Yep. So we have to install the ZFS drivers as well. And to do that, we do SPL, which is one of the package names, ZFS kmod, which is the kernel driver, and we have to rebuild the ZFS software. So SPL is the library for both of these. So in order of the dependency to its parent is the preferred order to install these, right? So and if we don't do this, then the ZFS file system software and driver will not be available on the new kernel version. And then after this, we're done. Ooh, what do we got here? Okay, so what we have here is a warning that reminds me that we're trying to install version 0.7.5. Now I know 0.7.6 is available, and what I have to do is unmask it or make it available to be installed, because this version doesn't support Linux 4.15. The new version does. So what we have to do, as can be seen here, with this package search tool, which is called EIX SPL, right? See, this shows all of the packages available matching your search string. So we've got version 0.7.5 configured to be installable, but we have to allow 0.7.6. And the same thing with the kmod or the kernel versions and the ZFS software itself. They all have matching versions, right? So to do that, what we do is go into this file, which configures versions of software that are allowed to be installed above stable. So we're going to uncomment this by changing it to 0.7.6. And then what we're going to do is go back up here, and we'll pretend in verbose to show us what it will change and any configuration settings for these three packages that we're going to install, and if there's any changes to those that may have changed since it was installed last. And there we go. So none of the configuration options have changed. However, custom C flags, that's something I might want to, I think I want to change that so that it doesn't use that, right? So what we're going to do is go into the package configuration file, and we're just going to copy these names, SPL -custom -C flags, and we're going to repeat that for the other packages with ZFS. That would be an incorrect spelling, but you know, you can Don't have to be a real professional to do this, or highly educated. I fat fingered my way through learning all of this. There. And what we'll do is we'll make a notation and name it ZFS, so that we know that those are at a later date specific to ZFS, right? So what we're going to do here is recheck our options, and we'll note that the custom C flags configuration option on those three packages have changed to exclude using custom C flags or compilation flags specific to a certain processor or optimizations for the software when it's built. And then we will just omit this and we'll build it. Now, after this is done, you typically just prepare to reboot, and when you reboot, everything should be working with the new kernel version. Like it goes without saying, and it's probably worth mentioning, that doing this takes a good amount of patience. But you know what you gain from the experience of doing this is far greater than, say, just using canned sardines, right? So I wonder how big is my video now. Let's look. I'm going to look at how big my video is while this is doing its thing. That's not too bad. It's only 240 megabytes. That's pretty good. So this for some reason or another, when it's checking and validating the options that it has to look for to configure the environment to build the driver for this PC and its configuration, seems to take longer. Like it's really verifying some very complex things. Even on my very powerful 20-core Xeon server, this takes quite a long time to do that verification and checking stage. So there we go. There's SPL is built. It'll install SPL and then go on to the kernel module or the actual driver for it. Checking things. I don't know what some of these things are, but it's necessary. And some of these steps with common programs that you do this with become easier to recognize if there's an issue you need to resolve or address. Some software that's missing, if it says no, that may provide a functionality or utility benefit, you can install that software and then rebuild the package that alerted you to it being missing. So being able to do this is like being able to build your own kitchen, car, truck, computer. Given this is doing it on a computer, I don't know, bake a cake, all right? You're just taking all of the raw ingredients and making it into something of substance, something from its bare ingredients or raw ingredients. Checking like file system access control list modes, which I know is available. IOPS is like file system performance. X attributes or extra attributes means more permissions and security environment settings for file systems, for more finite control over what users can do with permissions for files, security things, I guess. SOP's not sure what SOPs is. I guess, well, inodes are part of the file system storage mechanism in Linux. Usually this happens very quickly, so you don't get a lot of opportunity to really review what's going on, or what it's presenting to you when software is being configured before being built like this. It's doing all of its checking things. There's probably a more eloquent explanation for this than I'm providing at 6 o'clock in the morning while being thirsty. Am I the juice? I have some juice left. Good. Fortunately, I don't think the ZFS one takes as long. This file system is immensely complex, and more complex and involved softwares will occasionally require these longer configuration steps to do or to complete. It's also worth mentioning too that this Linux install is actually on a SATA SSD drive. So having an SSD drive isn't always going to help you with some tasks. It's not the be all end all. There we go, and that's the kernel modules for ZFS built. Now for the user software. Without user software, the other stuff would be unusable. Typically, you don't necessarily have to sit here and watch this stuff if you've got a lot of these updates to do. Nice thing about this is it's able to allow you to queue up a lot of builds, just tab out of it and go play a video game. So it's not an intimately boring task to the point where you have to sit here and watch this for hours and hours and hours. It's kind of like putting a turkey in the oven and going and watching a couple movies and checking on it later. You just have to be aware of the goals you want to achieve and what you want to accomplish by doing this. Excuse me. And it will in most cases, succeed. There we go, and we are done. So I'm just gonna exit out of the screen terminal, and we're gonna make it reboot. Now this computer generally takes a few minutes to reboot, but go Erebus. You probably have to do this a couple times just to see when it's come back up. And we'll show you that it has successfully booted from the new kernel version. And that will conclude our video. Video lesson tutorial on how to update a kernel in Gentoo Linux. Linux kernel. And there we go. And it's back. So and there we go. And it's running the new kernel version. We'll switch user to root so that we can use super user commands like verify that the zpool or ZFS software works. I don't have any drives configured in this thing to use ZFS at the moment. We're going to verify that the drivers for the Nvidia graphics card are loaded. Right, so that lists the loaded modules, and Nvidia, where is it? There it is. The Nvidia module is loaded. We can also look at this -K, and that will show us all of the devices and their associated drivers, or in this case, there we go. Here's the graphics card. Is using the Nvidia module, and the HDMI audio is actually using the high definition sound driver. So that's successful. And there we go. So welcome to Gentoo Linux.